Next, put a heading RLC circuit. Next one is what is that? RLC circuit. Can you switch off the slide? Okay, they will say it as a LCR circuit, but you need to remember it as a RLC circuit. Okay, RLC series circuit. Okay, series AC circuit. It's a very big topic, but we will make it very easy. Okay, so we will try to do it in that manner, and we'll use the phasor diagram. Okay, the phasor diagram can be two types, you know already. One is with a peak value, one is with a virtual value. So we'll use a virtual value and we'll try to complete it as soon as possible. Okay, chalo, pass. So when I write, you also try to write. Okay, now what is it now? I will consider one of the circuit like this. So which consists of resistance, inductor and then capacitor, all are in series. Yes or no? Now when they are in series and you are supplying, what is it here? One AC supply you are doing. Okay. Little bigger I will try to draw, so it will be easy for us. So one source I am taking. The source is actually a AC source. That AC source is this one, which is E is equal to instantaneous value of the EMF is what is that here? Sine into omega t. Okay. Sine into omega t. Or else we are supplying what is that here? Virtual value. What is this one? Virtual value, or else what you can say? RMS value. You know what is a virtual value? Meaning virtual value is nothing but peak value divided by root 2. Clear? Huh? So you are supplying a virtual value. Which value you are supplying? Virtual value. So here which one is this one? What is the component name? Resistance, inductor, capacitor. Right? Huh? Now listen here. Very simple. Inside this one, if you are supplying the virtual EMF, so inside this virtual current only flows, no? Am I correct? Huh? Which current it will flow? Virtual current. And this virtual current is a constant or not? So throughout the circuit now, virtual current is constant because it is a series, right? So virtual current will be constant throughout the circuit. Am I correct? So now inside this one, here if I try to show you, what is that? The conductor, the voltage drop across this one. Can I say voltage drop across this one is VL, and the current passing through this one is what is this real? IV. Is the same phase. In an inductor, I told you current will be lagging. Yes or no? Current will be lagging, and who will be leading, buddy? EMF will be, or voltage will be leading. Am I correct? So that is what I am trying to show. So here current is like this, IV, everywhere current will be like this only, no? Lead, yes or no? Now what happens here? It will be lagging and the voltage across the inductor will be leading by how much angle here? How much angle, right? Pi by 2. How much phase here? Pi by 2. Here how much it is lagging here? Voltage will be lagging or not in this situation? That is what is that here? VL. BC will be lagging by how much here? 90 degrees. So no, pi by 2 I can say. Nigashini. Got it? Huh? Draw the figure first. So I'll draw the phasor diagram related to it. Phasor, triangle I can say, diagram I can say, analysis also I can say, all are same only. All are same only. From this one, from the figure, all the things I am writing it together I will write. Yes or no? Now I will try to write. Here this is what is it here? EVL. The current will be like this only, no? IV. Everywhere IV only. and at the in capacitor it is what is it here, VC. Yes or no? Now what is that virtual EMF will be rotating. Yes or no? Everywhere virtual rotated. So EMF will be going. That virtual EMF I am taking it as a EV. Right? How much angle you are rotating here to here? Let's say phase angle is phi. And across this one, same line I will draw VL. VR can I write? Potential drop across. This is VR body. I am sorry. So potential drop across the resistance is VR. Like this. The phasor diagram you understood or not? Simple. We are not drawing the complicated with the peak value, but we are drawing with the virtual value. Is it clear? Okay. Are you clear now? So in this circuit few voltages are leading, few voltages are lagging, few are along with the phase of the current only. Am I correct? Which one here? VR is in the phase of the current only. Now there is a possibility. Finished? What is the possibility now? If in the case inductor is very strong, the potential drop across the inductor is very high. So as compared to the VC, it is very high. Yes or no? What happens now? So automatically the circuit will try to lead only. What is this one here? The circuit will try to lead. So I am drawing with the, you see the blue line. Can you see this line? So which will be, what is it here? It is a VL minus VC. Yes or no? Here let's say 100 volt. Here let's say 90 volt. Leading a lagging a? Leading only, because VL is high, no, potential drop across the inductor is high, so this circuit entirely behaves as an inductor. Yes or no? So what I'll write, it is a VL na. So if I close this circuit now, you see, if I close this triangle, why I am saying triangle, you see, this is a virtual value. Downside, what is it here? Potential drop across the VI, because of VL is higher, and this one I can write, this one will be closed like this. What is this one here? VL minus VC. Can I write like that? What is the phase angle here? Phi. What is the phase angle here? Phi. Can I write like that? Now from this phase, I'll get few things. One is a phase angle. What is it? I can get it a phase angle. Phase angle is nothing but tan phi. Tan pi is nothing but VL minus VC divided by VR. Can I write like that? So tan pi is also written as, what is that I can write? Tan pi is also written as XL. XL into IV. Can I write like that? XL into IV. Next XC. What is this? Reactance into virtual value of current divided by resistance into IV. Am I correct? So total phase angle will be, what is it now? It will be pi is equals to tan inverse of XL minus XC divided by R. Got the phase angle or not? Got it? No, done. Pass. This condition do not forget. VL is greater than VC. In regular days we will hear this one. Two phase current, two phase current won't be there. Three phase current, one phase current will. Yes or no? You hear it, right? Have you heard? Three phase current na it's little bit heavy power. One phase current na it is less power. Yes or no? Have you heard about it? Yes or no? It's because of this one. So in our home also we'll install this circuit, RLC circuit. In mobile also we'll install. Everywhere we'll install this. Clear? Huh? Shall I move on? Okay, buddy. Then next, from the same one, we will try to write one impedance. What is this one here? Impedance. Impedance is denoted with a Z. Means total resistance. How much of this circuit? So we have this. What is it here in our hand? We have this triangle, which is virtual value EV, and this one is VL minus VC, and this one is what is it here? What is this? We have a VR, and this is a phase angle is how much here? Pi, right? So if I try to write EV square is equal to, can I write VL minus VC whole square plus VR square? Yes or no? From triangle laws. So what is it here? EV, which is equal to under root of what is that? I can write it here. VL minus VC whole square into VR square. Can I write next in terms of current we can convert everywhere we can try to write virtual current we can write, right? Virtual current in the sense XL into IV minus XC into IV whole square plus IV into R whole square. Can I write like that? So totally what I'll get it here, EV is equal to IV, I can take it common, which is under root of XL whole square. Can I write like this here? R square plus XL minus XC whole square. Can I write? So if I just check it here, so Z is equal to, impedance is nothing but it is a ratio of EV divided by IV. Can I write like that? Virtual voltage divided by virtual current, which is equal to what is that here? R square plus XL minus XC whole square. Can I write like that? So that is your impedance. Next we have a power factor. Power factor is simple. Cos pi. Power factor is nothing but here cos pi. Cos pi is equal to, what buddy? What happened? Are you okay? Cos pi is equal to what is that here? VR voltage divided by and EV. Can I write like that? Voltage divided by U. Yes or no? Then after this one also we can write a resistance divided by impedance. What is it I can write here? Resistance divided by impedance. So cos pi is equal to what is it here? R divided by under root of R square plus XL minus XC whole square. That will be your power factor. Got it? Not Done? Any difficulty? No, right? Okay. Now few points we should learn about it. Okay, about this RLC circuit. Shall I move on? So what is a few points now? Simple points here. Have you completed this one? Write little faster, buddy. Little bit. Like this you write now, patient will die. Okay, doctor should be faster. Listen, daily how many you just talk to any doctor, a good doctor you talk to? Not a Josha, but a good doctor. You speak to a good doctor here. Neha is there, a very good doctor. Every day 40 or 50 patients she'll attend. Now you see Josha, she will write like slowly, that patient will die. Harish, I cannot imagine myself. If he becomes cardiologist, every day one patient. That's it. No need to frame, no need to do anything. Just pay to Harish, he'll kill. Really? Yeah? Chalo. He's my buddy, bro. He will choose everything. Okay. Shall we? Next. One simple thing here. One note if I try to write, certain note will try to understand. Note number one. Three notes are there. Okay. If in case, if a reactance XL is greater than XC, or else what can I write? Voltage drop across a VL is greater than VC. Then what happens, buddy? The entire circuit behave as a inductive circuit. Got it? Huh? The RLC circuit will be inductive circuit. If XC is greater than XL, means the reactance of capacitance or reactance of inductance, if I compare, if capacitant reactance is greater and voltage drop across the capacitance is greater than the inductance, what it will behave as? RLC circuit will be conductive. Next, last situation if I show you, if both are equal, XL is equal to XC, or else voltage drop across them is also equal, then what happens here? RLC circuit will be resistive circuit. Okay, so is there anything they mentioned here? Resistive. Okay, so how would I remember, how would I actually check it now? There is one more option also you have here. Here phase angle if I try to find now, here it will be positive. Here what it will be? Negative. Phase angle will be negative. In this situation, phase angle will completely zero. Got it, buddy? So there is one more option is also we have written phase angle also. Phase angle here positive, here negative, here zero. Is it done, buddy? Is it done? Shall we move on? Okay. Nikashani, are you writing? Completed. Then power observed, because every circuit we are trying to follow power observed, right? Right on. Power observed. If in a case, because we will try to see XL value is greater than XC, because this circuit now behaves as inductive or not. In inductive circuit, yes or no? RLC circuit now what is it here? Is inductive, right? So instantaneous power. Instantaneous power, which is a P instantaneous, will be equal to instantaneous EMF and instantaneous, what is that here? Current of that particular circuit. So here automatically what it will convert? So instantaneous, how much you are giving here? Sine into omega t, and we know already instantaneous current will be I naught into what is that here? What is that, Ray? Cos of omega t. Remember this one? Yes or no? So P instantaneous is equals to, we will write it as a E naught I naught, E naught I naught, and that's what. So E naught I naught sine of omega t, and this one also can I write it as a cos omega t is, cos omega t, and here cos omega t, it's with certain, I will not write a cos omega t completely, but instead of I will write a sine of omega t minus some pi angle, because it's not completely inductive. It's not pure inductive, right? It's not exactly pi by 2, but it is like pi angle I am taking, right? So what happens now in this situation? So here few things we'll try to write. So we'll multiply 2 and divide with the 2. So here sine of omega t, and here sine of omega t minus some phase angle is pi. Separately I am writing this part. So what happens here? P instantaneous formula will convert as a E naught I naught divided by 2, and the remaining part, this will be written as a 2 sin omega t minus pi. Now the formula will be cos pi minus cos of omega t 2 omega t minus pi. Do not forget it, minus 2 omega t. Got it? Now we will find a power average. Power average, only the observed power, which is nothing but integration from 0 to t, P instantaneous. Am I getting here? Next situation, what is that? You will apply the integration E naught I naught divided by 2. You will apply integration 0 to t cos of pi, and we have a dt. Yes or no? Then minus 0 to t cos of omega t minus pi into dt. So now obviously we one entity we learnt, remember 2 omega t, if it comes automatically it will become a 0. So this entire term, even though if I do integration for a 1 pi g, it becomes a 0 only. So we will neglect it. So what is the answer? I will get it now simply. Okay. That's it. That will become 0 anyhow. So we will get it as simple answer here. So your answer will be, what is that here? Are you getting my point? So power average is equals to, you will get it as E naught I naught divided by 2 into cos pi. That will be your, at last you will get the answer like that. Chalo, do it. This is a average power over a cycle. Yes or no? That's it. Is it done? Guga. Guga. Shall I move on, buddy? Okay. Shall I move it? Okay. Few other things also I'll try to do. You tell me something like that. P average is equals to what is that I got it? E naught peak value I naught divided by 2 cos pi. Yes or no? Can I write it like this here? E naught divided by root 2, and this one is I naught divided by root 2 into cos pi. What is the answer I will get? Tell me. E virtual I virtual means RMS values into cos pi. That is your P average. Am I correct? Then next one more thing also I can do it here. Since you know that cos pi value is already R divided by Z, right? Yes or no? R divided by Z or not? Yeah, we know already this one. So here in this one I will try to implement few points. Can I write? So power average is equal to, which is equal to what can I write? EV into IV into, we have it as a R divided by Z also we have. Now for example, I will take here, if in the case EV is equal to, can I write Z, because totally what is it here? RLC circuit. So impedance into what is it here? IV I should write. So power average will convert into which format here? Check it. So power average is equals to, so here Z into IV into R divided by Z. So what happens here? This impedance can I cancel? So it will be IV square into R. Can I write a? Yes or no? Next, if I case if I wanted to remove a IV value, what will I write? IV is equal to, can I write EV divided by R, not R but impedance Z I am writing, because RLC circuit, right? So what happens here? Power average is equal to what you will get it here? EV square divided by R, you will get it. Just check it now. These are all the formula for power absorb. Formulae. What is this, Ray? I just studied it as a power factor. You got it? Same answer? Yes or no? Next, write down RLC circuit in a parallel. That is not there for the CBSE. This is there for CBSE also, but in a parallel it is not there. For parallel, what we will write? Admittance will come. Okay. So RLC, parallel circuit in AC. Shall I write like that? So next RLC, parallel circuit in a AC, alternating current. Parallel circuit is also important. For NEET and JEE, it's very important. Okay. Here some other term will define, that is a admittance. What is it? Admittance. So one AC supply, will take it like this. Resistance, inductance, capacitance. Draw it. What is that you are giving a virtual value, or else you can also say instantaneous value also, we can say it. Okay, like this current is there, this is a resistance, this is inductance, this is a capacitance. So every point what happens now? Virtual value will be same, am I correct? Huh? Yes or no? Potential difference across them is same only, but virtual value will change. So phasor diagram with phasor triangle we try to draw. Shall we? What is the phasor diagram? Now it will come with the, what is the current? Current will lead a lag, like that it will come. Okay. Now first of all, in this one, resistance law, who will lead, who will lag? Current will not lead, current will not lag also. It is zero phase difference. So here I will show you something. Wait. So here virtual current will rotate. So basically I will take one of the axis like this. Who will rotate like this na? Virtual current. You call virtual or virtual? Virtual only, no? Along the resistance, current will not lead or lag. So I will write I resistance. Current in a resistance. Current in inductor will lead a lag. Lag. Yes or no? So it will come down. IL will be coming down. Above, who is there here? Capacitor. Current will lead. So it will come it as a IC. Okay. Phasor diagram. Phase angle. Is it done? So if in case, if I am taking the conductive side, because current will lead right in this one. So if IC will be greater than IL, what happens now? You see this one line I will try to take with green color. Shall I take it? So IC is bigger than IL na. Current will automatically lead in this circuit, which is this one, which is what can I write? IC minus IL. Can I write like that? IC minus IL. Can you see this green color line like this? Right? So now I will draw the triangle. I will get one triangle. What is that here? This is, you will get it as, it is a phasor triangle. Virtual value, resistance value, and this one is, what is this here? IC minus IL. This is a phase angle. What is this angle here? Phase angle. phase angle, right? Can we write all the things now? Now phase angle. Phase angle tan phi is equals to, I can write a IC minus IL divided by IR. Yes I know. Next, power factor. So instead of power factor, I will first do few other things also. Admittance. What is it I want to find now? Admittance. Admittance denoted with a Y. Nothing is there. Admittance is nothing but what can I write? You see how it will come. IV square is equal to what can I write here? IC minus IL whole square plus IR square. Can I write? Then from this one, IV which is equal to under root of IC means what can I write, buddy? IC means can I write it as VC divided by X means reactance C can I write minus here also VL minus this is XL whole square, then plus we have one more thing here, here VR divided by X R, sorry not XR, I can write R directly, I can write R, okay. R whole square. Can I write like that? Now we know that VC is equal to VL is equal to VR is equal to what is that here? E virtual value. Yes or no? Now can I take it all outside? So IV which is equal to EV I can take it out. So which will be under root of what is that I have? So 1 divided by XC 1 divided by XL whole square plus 1 divided by R square I can write it. Can I write like that? Now admittance is simple here. Formula so I can try to write now finally. So Y is nothing but it is the ratio of virtual value of current divided by EMF, which is equal to what is that here? Under root of this entire thing you can write, which is 1 divided by what is that here? XC minus 1 divided by XL whole square plus 1 divided by R square. Can I write like that? That is your admittance. Admittance is also equal to 1 divided by impedance. Is it done? Will be test notes. No. Take it. Okay. So power observed and power factor will be same only, but no changes. Power observed and power what is it? Power observed and power factor will be same. Okay. For this RLC circuit in parallel. Any difficulty now? No. Now we can move. Thank you. See you. Okay guys, move. Thank you. Shall I discard? Judean.